for this quick here for the arithmetic 579, right? It is is n. Tn is equal to 3 plus 2n minus 2. Then our last would be 2n plus 1, right? I added the two like terms, the 3 and the negative 2 together, and we got a plus 1. So now that we've found that, that's the general term, right? That's the solution for this. So if you got that, you get 2 out of 2 marks, right? You get, if you've done anything else, if you've shown this, right? I'd give a mark for that, all right? But if you get the right answer, you automatically get 2 out of 2, all right? Provided you showed some mark. Now, if you just have the right answer, you get 1 out of 2, if that's it, if you don't have anything else shown. Because obviously you've done some work, but you haven't shown me what work you've done. So you need to show some kind of work and have the answer in the box there to get 2 out of 2. Now, because we know this and we're not changing the sequence, for T8, all I really need to know is that n is 8. So T8 is equal to 2 times 8 plus 1. That's 16 plus 1, that's 17. Some of you may have thought, well, you know what, n is 8, a is 3, d is 2, let's find T8. And you went back maybe all the way to the top formula there. That's fine, you can do that. So T8 is equal to 3 plus 8 minus 1 times 2. You get 3 plus 7 times 2. 3 plus 14 is 17. You should still get the same answer. Either or, right? Just know now, though, that we found the general formula, right? So it's going to work all the time. That's why we define the general formula. In general, this is going to work for the rest of any of these examples in this particular sequence. So T25, I'm just going to do it the easy way. N is 25. So T25 is equal to 2 times 25 plus 1 is equal to 51. Okay, so the 25th term is 51. So it's a lot easier than if we were to write out 25 terms. Especially what if I said, what's the millionth term? You're not going to write out a million. Hopefully you're not anyways. Now the description, D. Describe how to find Tn. Well, I'm going to write it in point form, right? I substituted A and D into the not the general formula, the arithmetic sequence formula, which is Tn equals A plus n minus 1 times D. And I solved for Tn in terms of n. And if you want, you can put the parameters or the variables in brackets there. Okay, so something along those lines. So basically what you had to do is say, you know what, I looked at the sequence, I figured out what A is, I figured out what D was, I knew that N is just N for the general formula. I substituted those into the arithmetic sequence formula, and I got a equation in terms of N. If you do that, you get your mark. Okay, so again, these are all worth 1 mark, 1 mark, and 1 mark. If you look at the back page of your quiz, it looks like this. And what it says is, this is just a recap for yourself. Okay, question 1 on relations and functions. That's the topic we're on right now, is relations and functions. Number 9 in your curriculum, right? And if you're wondering, what's he talking about curriculum? Remember I said everything's tied to your curricular outcomes, and I do have a copy of it here. It's on the bulletin board. So here's what they are. Here's specific outcome 9 for relations and functions. And it says that you're going to have to, from question 1, right, 1 and 2. So identify assumptions made when defining an arithmetic sequence. So that's more of part D, when we kind of explained what it was, right? And provide and justify an example of an arithmetic sequence. You didn't have to provide it, but you had to work with it, right? And actually derive a rule for determining the general term of an arithmetic sequence. Okay? So there you go. And you can see from what we've talked about throughout the first 4 lessons in here, we've talked about arithmetic sequences and how they are related to linear functions. Okay? We determine T1 and D and N or Tn. Okay? We've done that. Derive a rule for determining the sum. We've already looked at sum as well. But these particular questions just are the straightforward ones. They've looked at the first 3 achievement indicators, or the first 3 specific outcomes. Okay? So if you got the first question right, you can say, you know what, I achieved that. I got it. I got that part of it. Okay? If you haven't, well then check this. That's fine. And maybe make a comment, right? Was not sure how to find Tn. Okay, so maybe you had a problem with A and D. You didn't know how to find Tn. Okay? And then after you do question 2, or after we do question 2, you can look through those as well, right? And just say, okay, question 2. Now, do you have to know these word for word? No, obviously you're not going to memorize the achievement indicators, but I will have these up on the wall, and you can take a look at them whenever you want. So whenever a quiz or an exam has this, you're like, okay, well, what am I supposed to really know from this question, right? Besides that it's an arithmetic sequence. You can look through these, okay? And for some of you, that will really cement why we're doing this. For others, it'll be just an added bonus that might help. Okay, question 2. David starts work for a company at a salary of $17,000 per year and receives a raise of $3,000 per year every year. Use the formula. Oh, that's nice of them. They give you the formula, right? But again, you made your own formula sheets that you bring in, or if you want to call them your cheat sheets, your foldables, whatever you call them. So you should have had that. Determine the year when David's salary first reached $50,000. So I'm just going to write out the first couple. Okay? So there is our formula, or sorry, our sequence. So A is 17,000. D is 3,000. I had somebody ask, well, wouldn't it, if he gets it every year, wouldn't he get 20,000 right away? Well, no. Doesn't make much sense. If they're going to say, well, we'll give you 17,000, but we're going to give you a bonus before you start, why wouldn't they just say we're going to start you at 20,000, right? So you're going to work for the first year at 17 and then add 3,000 per year. Tn is going to be 50,000, or it might be a little bit above 50,000. Depends what it is, right? We're not sure. Will it actually hit 50,000 exactly? We'll find out. So we'll put 50,000 here, okay? And then really what they want to know is n. What is n? So 50,000, again, I'm using this formula, right? 50,000 is equal to 17,000 plus n minus 1 times 3,000. Remember, use brackets. Makes it a little neater. Now, hopefully you're all comfortable with these operations that follow because we've done this many times. We distribute this in. So we get 50,000 is equal to 17,000 plus 3,000 n minus 3,000. Right, add the two like terms, the 17,000 and the negative 3,000. So we get 50,000 is equal to 14,000 plus 3,000 n. Right? Subtract 14,000. It's going to get a little messy here. Let's change colors. Subtract 14 from both sides. Why do we subtract 14? Because we want to get that to 0. So we made a 0 here. And on this side, we're left with 36,000. And we still have the 3,000n. So let's divide by 3,000. Divide by 3,000. Again, why are we dividing? Right. Are we going to get rid of it, but we want to make a 1, right? So we're not magically making it disappear. We're getting an understood 1 out in front of that n. So n is 12. And it did work out perfectly. If that would have worked out to a decimal, then we would have had to go up to the next year, right? If it would have been 12.1, we would have to say, well, it wouldn't have reached 50,000 until the 13th year because at the 12th year, he still wouldn't have been quite there yet. But it did work out nice, and for the most part, it's going to work out nice that 50,000 actually worked, right? Okay, so 3 marks. 3 marks. 1 mark if you started the problem in the right direction, whether you showed this, whether you showed that, right, any of those things, or you got to this point where you substituted it in, okay? 1 other mark for getting the answer, okay? And then the last mark always on a problem is answering the question. N equals 12. Well, what's n equal? I know that. I'm your teacher, but someone else may not. So it'll be the... Right. David will reach a salary of $50,000 in 12 years. Okay? And again, you're not going to have to do an obscene amount of these, so you can write out a sentence. It's not going to kill you. All right? So again, look back now. Go back, reference this. Did I get that? Yeah, I got it. Okay. Well, which ones were they actually doing? Well, they're doing the same thing there. Okay. So 9.1, 9.2, 9.3 from your specific outcomes. Yeah. Okay. So the question was, I combined these first. I took the 17,000 and the negative 3,000 and made 14,000 out of them. Right? You got to combine like terms first. If you're going to do it separately, I would have had to subtract 17,000 from both sides. Then I would have had to add 3,000 to both sides. Or I could have just made it 14,000 first. Okay? Good.